This is a quick video to look at chemical formulae, which you will find in Unit 1, Topic 5. The spec asks us to recall the diatomic elements, which means learn them. We need to interpret chemical formulae and we need to write chemical formulae. So, first of all, let's have a look at our diatomic elements. There are 7 in all. You've already met 4 of these: hydrogen, nitrogen, oxygen, and chlorine in Topic 2, which was bonding. There is a quick rhyme to help you remember the 7 diatomic elements, and that help our needy class find grains immediately. So let's interpret chemical formulae. So on the left-hand side, there is a list of chemical formulae, and we're going to look at how many elements are present and how many atoms of each element are present. So, for example, sodium hydroxide has 1 sodium, 1 oxygen, and 1 hydrogen, which is 3 atoms. If we then look at sulfuric acid also has 3 elements present. It has hydrogen, sulfur, and oxygen, but this time it has 2 hydrogens, 1 sulfur, and 4 oxygens, so it has 7 atoms in total. Pause the video and try the next 4. We now meet an example that has brackets, and we're going to treat the brackets just as you would do in maths class, and we're going to multiply them out. So this is a formula for aluminium sulfate, and this tells us that we have 2 aluminiums, 3 sulfurs, and 3 by 4 is 12 oxygens. Pause the video and try the final 3. Now let's see how to write those chemical formulae. You're going to need your periodic table, and your periodic table is going to be really important because it's going to help you find out the valency of the elements in the compound. What is a valency? Well, let's go back to bonding and let's look at a very common example of an ionic compound, sodium chloride. And you probably already know that the formula for sodium chloride is NaCl. And that's because sodium is 281, it wants to lose 1 electron. Chlorine is 287, it wants to gain 1 electron. So sodium transfers 1 electron to the chlorine atom. So we need 1 sodium and 1 chlorine. You might remember from bonding that if you move on to magnesium and make magnesium chloride, you're going to need 2 chlorine atoms because magnesium wants to lose 2 electrons, but chlorine wants 1. So what we're going to learn is a new phrase called valency. And valency is linked to the number of electrons an atom wants to lose or gain. So you'll see group 1 has a valency of 1, group 2 a valency of 2, group 3 a valency of 3, group 4 a valency of 4. Watch now, because group 5 has a valency of 3 because it wants to gain 3 electrons. Group 6 has a valency of 2, and group 7 has a valency of 1. You're going to need to know these valencies whenever you do your chemical formulae. You might find on the top of your periodic table, you might see it written sometimes, people will put the valency above the groups. So let's see how we use valencies to write a chemical formula. First of all, we write down our compound. In this case, we're going to do potassium chloride, and we're going to use a technique called swap and drop. So start by working out what group potassium is in and what group chlorine is in. That will give us our valencies, and we're now going to swap and drop the valencies. What this now tells us is I need 1 potassium and 1 chlorine. So my formula is KCl. When you get to the swap and drop method here, just make sure you ask yourself, is this the lowest whole number ratio? And in this case it is. If we move on to aluminium chloride, aluminium, remember, is in group 3, so it's a valency of 3, and chlorine is in group 7, it has a valency of 1. Swap and drop. This time you're going to need 1 aluminium and 3 chlorines, and that makes sense because aluminium has 3 outer shell electrons, but chlorine only wants 1, so we need 3 chlorines. If we have a look at this example, this is iron 2 oxide, and iron is a transition metal. So we wouldn't know the valency because iron is in the block between group 2 and group 3. So the Roman numerals tell us the valency of the element. So in this case, it tells us that iron has a valency of 2. Swap and drop again. This time you'll notice that you have a 2 to 2 ratio, and we can reduce that ratio to 1 to 1. So our formula is not Fe2O2, our lowest whole number ratio is 1 to 1. So in this case, the formula is FeO. So just watch that whenever you swap and drop. Just ask yourself, is that the lowest whole number ratio? Moving on to doing formulae with molecular ions. You're going to find your molecular ions on the back of your periodic table. And these are little groups of atoms. So here's our nitrate. And we have 1 nitrogen and 3 oxygens. And it has a charge of -1. So it is a group of atoms with a charge. -1 will tell us the valency. The valency will be the size of the charge. So nitrate with a charge of -1 has a valency of 1. Sulfate down below has a charge of -2, so it has a valency of 2. And you'll find all that information on the back of your periodic table. So let's see how we do swap and drop with molecular ions. So here's our example, lithium nitrate. We're going to write down our molecular ion that we will have found on the back of the periodic table. We know that it has a charge of -1, so it has a valency of 1. Swap and drop, and we can see that our formula is LiNO3. If we change now to magnesium nitrate, magnesium has a valency of 2, nitrate still has a valency of 1, and we swap and drop. This time our swap and drop tells us we need 2 nitrates. This is where we have to use brackets. If we didn't use the brackets, it would look like we had 32 oxygens. And we know that we have 2 nitrates, which of course is 2 nitrogens and 6 oxygens. So therefore we use the brackets in this case.